So in this question, we have a spider which is hanging at a distance d is equal to 2r by root 3 from center of a transparent globe of radius r, and it is above its north pole. Refractive index of the material of globe is 2. Then between which latitudes a fly should be on the globe so that the spider cannot see it, and treat the spider and fly both as particles. So here is our situation. So here is our globe, and this is the north pole, and this spider is flying, actually hanging at a distance d is equal to 2r by root 3 from the center. So spider is somewhere around here, and the distance of spider from the center of the globe is nothing but 2r by root 3. So this distance is 2r by root 3. Now see, question is between which latitudes a fly should be on the globe so that the spider cannot see it. Now for example, suppose the fly is somewhere here. So spider can directly see the fly because light from fly can come to the spider. So we have to find all the possible positions of the fly for which light from fly cannot go to the spider. So first of all, if we notice, if we draw tangent from the spider to the globe, so this will be our tangent. So between all these positions, if you see between all these positions, the spider can directly see the fly. Now what about the other points? Suppose we assume, let's say that fly is somewhere around here, directly on the opposite end. So obviously light from here will enter the globe, transparent globe, and it will come straightly outward and directly to the spider. So if the fly is somewhere here at the bottom point, obviously the spider can see. So we have to find the possible positions where the spider cannot see the fly. So instead of thinking about light going from fly to the spider, let's analyze what all rays can come to the spider. Rays that can come to the spider are this one, like this, some rays like this, and between these two tangents only. So we have to find the positions. Suppose for example this ray will give a directly opposite end. So if you see if you consider this ray, this is the normal, and this is the angle 90 degree. If you analyze, suppose here if we take the angle of incidence is 90 degree, so rays will be refracted here, and suppose it goes somewhere like this. If the fly is somewhere here, so rays will travel like this, and this has to be the critical angle, and rays will go to the spider. Now from fly, rays are coming out in all directions. See, from fly the rays are coming in all directions. So we are only considered that ray which can reach the spider. That's why we are drawing this line. If this is the ray and this is the critical angle, this ray will reach the spider. Rest of all the rays will reach at different points. Now for any position between these positions, between this point to the symmetric point on the opposite end, the fly can be seen by the spider. So all these positions, the spider can see the fly. And from this position A to B, from A to B also the spider can see the fly from this position also. So what are the position that is left is from B to this point and from A to this point. So these are the positions for which if the fly is sitting here in these positions, the spider cannot see it. So this is our diagram on one side of the hemisphere. So the light from the insect is going at critical angle theta IC, it is reflecting, it is refracting, and then it is reaching the spider. So this is the condition, limiting case. Now first of all let's calculate the theta c. So we know 2 sine theta c is equal to 1 sine 90 degree, because it was given the refractive index of the slab is, or the globe is 2. So we have sine theta c is equal to half, that means theta c is equal to 30 degree. So we have this angle as 30 degree. Now if you see this line, this is also r and this is also r. So this is an isosceles triangle. So if this is 30, this angle will also be 30 degree. This distance is r, and this entire distance is 2r by root 3. So let's write this angle as suppose alpha. So in this triangle, you see in this triangle, cos alpha will be base, that is r divided by hypotenuse, 2r divided by root 3. So cos alpha is root 3 by 2, that means alpha is equal to 30 degree. So this angle is also is equal to 30 degree. So now we have to express in terms of latitude and longitude. So this the position A, and this was the position B. So this is the position C, and similarly here we will have a position called D. So we know between A to C, if the insect is between A to C, the spider cannot see it, or between B to D. So from the center, if you see, this is the position. So if we draw a horizontal, basically the equator. So if this angle was 30 degree, this angle is 60 degree. So the position A from center is 60 degree. So we can say 60 degree north. And let's look at this extreme position C. So in this triangle A, C and O, this angle is 30 degree. This angle is 30 degree. So that means this angle will be 120 degree. And this was 60 degree. That means this was 60, this is 120. So this angle will also be 60 degree. So this is the other extreme position C. So the insect can be from between A to C, that means 60 degree north and 60 degree south. Similarly, other side also 60 degree north and 60 degree south. So if the insect is between these two positions, the spider will not be able to see the fly, and if it is between A to B, it can directly see it. If it is between C to D, it can see by the refracted rays. So answer would be between 60 degree north and 60 degree south.